I will be talking about design patterns and how I see the future of software engineering. I'm Anna, and I work for Marley Spoon for around 3 months now, and I've been living in Berlin for 2 years and a half. Just a quick intro. So I will have some sections for the night. So I'll have like summary now. So basically what I will talk about is what are design patterns, why use it, some future related topics that I think that match the topic, and how I think it can help shape the future of software engineering, and patterns and future, like we're talking about patterns itself. So what are design patterns? So I have I have some references in the end of the presentation. So where is the place where I took those info from? So I try to be like very I try to resume it a lot, but I don't know if it gets like too resumy. But design patterns are general and reusable solutions to solve some occurring problems in software design. For example, when you are designing a software that you need to use, and you cannot, like, it's not good if you just start throwing code. You have some solutions that are already like very well structured, and you can use it to pre-customize your code, so it's in a way that is more readable, more reusable, flexible, and everything that might help your development along the way, not only when you are starting it. So they are not algorithms, but they are more like general concepts on how to solve a problem. So you have a lot of problems that you might encounter, and they just help you to have concepts on how to implement that in a easier way. There are three main classifications for patterns. Those are the ones I will talk about tonight. The creational is about creation mechanisms to make objects more flexible and reusable. Structural, that explain how to bring together objects and make it more efficient and flexible, so we can reuse them when we need, and everything just settles together in a better way. Behavioral deals with effective communication and assignment of responsibility. So it's more around where you settle the things and see if everything makes sense and if it's reusable for the future. So why use it? Design patterns are a set of tried and test solutions. So even if you don't need all of them, we will see 23 tonight very quickly. It's still nice to know them because it helps with your thinking. So how you think software in general. So it helps you to understand better. Like if you use it, it's better for other people to read it. So as it says in the second topic, like if your team have a good understanding on design patterns, it's easier to communicate efficiently. So you don't need to be explaining everything that is happening. It's just like there, and everyone can understand the idea behind the concept you are implementing. So I've brought some future related topics that I think that might relate to design patterns. The first one is continuous integration and continuous deployment. And the reason why I think that that's very important for the future is that software is growing a lot in the past years, and we need to have ways to always be interacting with the software and always releasing new stuff. And that's and continuous integration and continuous deployment is a way to automate and assemble builds from developing to live or production easily in a reliable way. So with that, teams can release apps much faster and can be like always interacting with customers and public in general. Progressive web apps. So nowadays we have lots of different screens. We have phones, we have smart TVs, we have monitors and laptops. So we need to find a reliable way to guarantee that our project will work in all kinds of possible views. So I think that design patterns are related to that, because that helps you to find like a way to make something more general, but in the way like flexible enough to relate to those trendings that we see in the future. And last but not least, it's Internet of Things. And like Internet of Things, for the ones that don't know, is like interacting with sensors and devices that help you, for example, like we have Roomba, for example, that cleans the house and it's an Internet of Things and communicates with you. And for me, the vision I have is that, but as it can offer various advantages, we need to keep in mind that evolving software needs to be reusable and easily handed over when necessary. So we need to have some patterns in mind to make it easier to make this technology move forward. How it can help shape the future, on my view. So design patterns are beyond programming language, which means that you are not dependent on any structure to apply those ideas. So you don't need to have like this specific language which works with this specific pattern. This is just more a general concept that helps you implement in any language. So it's really good to have in your mind when you are developing. As mentioned before, once the teams have knowledge on those patterns, it facilitates conversation in development process. Why did I add that here? Because now everyone is mostly working remotely, so we need to find ways to be more efficient when we are talking to someone, to make everyone aligned in the team and make sure that everyone's understand what's going on and what will be implemented. So I think that that's a nice use for the feature we have right now. It also helps developers to build reliable and reusable prototypes because those general concepts are tested, so it's easier to plan an architecture of a solution. And also by building flexible structures, we can speed up changes on development, which relates to CI, continuous deployment and continuous integration. So I will quickly give an overview of the patterns that I've been studying in the past months. So there are 23. So mostly all the time, not everyone uses it a lot, like all of them, but if you get to a good knowledge of them, it's already really good. So as I said, there are three main classifications. The first one is creational. It has like 6 patterns inside of it. The abstract factory, which creates an instance of several classes, families of classes. So then the builder, which separates object construction from its representation. The factory method, that creates an instance of several derived classes. So for deriving classes in itself, it's a very used one. Object pool, which avoid expensive acquisition and release of resources by recycling objects that are no longer used. So you are refactoring some parts that you already have, but you are not using that much. So prototype, a fully initialized instance to be copied or cloned. So you can work with the prototype you already have. And singleton, which is very popular as well, a class of which only a single instance can exist. So you always have this one instance that exists of a class, so you don't need to be re-instancing all the time. The second one is the structural classification, and it has 8 patterns inside of it. So the adapter, which match interfaces of different classes. So you can pass through them in the interface. The bridge, separately, which separates an object's interface from its implementation. The composite, it's a tree structure of simple composite objects. The facade, which is a single class that represents an entire subsystem. The flyweight, which is a fine-grained instance, we'll use it for efficient sharing. And private class data, which restricts extra mutator access. And the proxy, which an object representing another object. So the behavioral, there's a lot. And I promise that I will be working on. After that, we just get the intro for that. So the first one is chain of responsibility, which is a way of passing requests between chain of objects. The command, which encapsulates a command request as an object. The interpreter, which is the way to include language elements in a program. So yeah, I could like explain them, but I will keep to what I wrote. So the iterator is sequentially access the elements of a collection. The mediator defines simplified communication between classes. The memento, which captures and restores an object's internal state. The null object, which is designed to act like as a default value of an object. So yeah, and the observer, a way of notifying change to a number of classes. So you have one main class that notify the others when it's necessary. The state, alter an object's behavior when its states change. And the strategy, which encapsulates an algorithm inside a class. The template method that defer the exact steps of an algorithm to a subclass. And the visitor that defines a new operation to a class without change. That's basically what I wanted to bring up tonight, so we can have like this quick overview and understand how it can affect the future of software development. And those are the references that I use, the Refactoring Guru and some top 10 software developer trends for 2020 and the Gango 4 book. That's it. So I'm open to questions now.
What is your favorite pattern?
Oh, the one that I'm enjoying more now is the one that I spend like more time on it are from the creationals one. And the prototype and the singleton, because the singleton is something that I've heard a lot during university, but I never took the time to like fully understand how it works. So now I'm taking the time to really understand what the teacher was talking about, and I really could fully understand like how it works deeply. So are there any old parents that are no longer used? So I can only give my opinion because I've been studying that for some time now, but I don't see like many people using, for example, the object pool, like when you avoid expensive acquisition. And there are some other ones that I don't see it happening like too much now, but I think most of them, like as I said, like is a general concept. So that are no old patterns are like things that are no longer used. They are always like kind of being reinvented. So as a general concept.
So can you give us an example of a pattern that you have used in the past months?
Yeah, so I've used for example, the bridge in the past few months. And what I use that for is that we have like a main service that has a lot of like specific calls to an API. And we use a main class to have some predefined methods that the children's class might use. For example, like, so they need to implement those in the classes that will use the bridge. So that was one of the last uses that I had.
There is one more question. Are design systems of value and importance to you from a UXer?
Yes, because if you don't design your system if you don't take the time to design what you are going to develop, then you don't have like a good structure for your app in first place. And you need to have this structure to build like a good product that will go out. And sometimes it could be something very delicate. So of course you need to have something, some kind of like design, a system designer, or you gotta have like an architecture that you see fit for the product that you're developing. So yes, of course, it's very of value and important for me.
Thank you so much for your talk, Anna. It was great, really informative.